You've probably used it today and didn't even know it. We're talking about RocksDB, the high-performance engine that's quietly powering some of the biggest, fastest data systems on the entire planet. So let's dive in and see how this thing actually works.
All right, first, let's set the stage a little. Modern apps, everything from your social media feed to real-time analytics, they face this incredible challenge. They have to swallow a constant, massive fire hose of incoming data, and they have to do it all without even breaking a sweat.
And that leads to the big question, right? When your app is getting absolutely hammered with thousands, maybe millions of writes every single second, what kind of storage engine can possibly keep up? How do you write that fast and still read data back in the blink of an eye? This was the problem that desperately needed a new kind of solution. And the answer, which was really born out of necessity, was a brand new kind of engine. This is the origin story of RocksDB, a piece of tech engineered specifically to take on this massive-scale data challenge head-on.
Now, what's so interesting here is that RocksDB wasn't built from the ground up. It actually started its life as a fork of another project, Google's LevelDB. See, LevelDB was good, it showed a lot of promise, but under the crazy, relentless write pressure at Facebook's scale, it started to buckle. So, back in 2012, engineers there took its core ideas and just supercharged them for a whole new level of performance.
So, what did they actually do? What are these technical superpowers that make RocksDB so incredibly fast and efficient? Okay, let's pop the hood and get into the mechanics.
The secret sauce really is an architecture called a log-structured merge tree, or just an LSM tree for short. The core idea is simple, but wow, is it powerful. Instead of writing data directly to its final spot on a disk, which can be slow, an LSM tree cleverly batches up all the new data in memory first. This makes writes just unbelievably fast. Now there's a trade-off. Reads can get a little more complicated because your data might be in a few different places at once.
Here's the breakdown in 3 simple steps. First, new data gets ingested lightning fast into an in-memory table. Once that table is full, boom, it gets flushed to a brand new, unchangeable file on the disk. Then, quietly in the background, a process called compaction tidies everything up, merging all those smaller files into bigger, more organized ones. This whole process keeps things running smooth, and it also solves that read complexity we were just talking about.
And this is where RocksDB really put the original LevelDB design on another level. It introduced multi-threaded compaction so that background cleanup process would never become a bottleneck. It added things like column families to group related data together and Bloom filters, which are a really clever way to quickly check if a piece of data doesn't exist, saving you from tons of pointless disk searches. People often call it LevelDB on steroids, and yeah, for very good reason.
Okay, all this technology is fantastic, but where does it actually matter? Where does the rubber meet the road? Let's take a look at how RocksDB powers the real-world systems you and I use every single day.
I mean, just look at this list. The technologies that rely on RocksDB are a literal who's who of modern data infrastructure. We're talking huge streaming platforms like Apache Kafka and Flink, which use it to manage all their state. And then you have these next-generation distributed databases like TKV and CockroachDB, and they use it as their fundamental storage engine.
This quote really just says it all, doesn't it? RocksDB isn't just another component, it's the fundamental backbone that makes the real-time performance of these massive, essential systems even possible.
But of course, RocksDB isn't the only game in town. To really get where it fits in, we need a little context. So how does it stack up against some of the other major players in the key-value storage arena? This table gives us a great little snapshot. So compared to its parent LevelDB, RocksDB just scales way better and handles lots of simultaneous operations much more gracefully. Then you have something like LMDB, and RocksDB's big advantage there is its tunability. You can tweak all these little knobs to get it running perfectly for your specific needs. And when you put it up against Wired Tiger, the engine behind MongoDB, RocksDB is often a lot leaner, which makes it perfect for embedding directly inside another application.
Now there's another massive part of the RocksDB success story. It's not just about the technology, it's about the people. Its whole development model has been absolutely key to its incredible adoption.
See, at its heart, RocksDB is a completely open source project. That means its code is out there for anyone to look at, to use, and even to help improve. And this collaborative model has been a huge driver of its success.
And you can really see the power of that community in this number. That's over 25,000 stars on GitHub. And each one of those is basically a vote of confidence from a developer out there. It's just a crystal clear sign of the trust that the entire engineering world has placed in this project.
And you know, ultimately, this is the legacy of RocksDB. Through its powerful design and that vibrant open-source community, it has become the default, the absolute go-to engine for anyone building data-heavy applications that need to operate at serious scale.
So we've seen how RocksDB solved a critical problem for its time. But, you know, data volumes are only getting bigger, hardware is always evolving, and it leaves us with a really fascinating question. What challenges are going to define the next generation of storage engines? What will the next chapter of this whole database story even look like?